Hello everyone, welcome to the solution of LeetCode problem 90 named subset 2. In this problem, we are given an integer array. The array can contain duplicate elements and we have to return all possible subsets of this array. There is a constraint which is the solution set must not contain duplicate subset and we can return the subset in any order. Let's analyze the first example. In the first example, the array contains 3 elements, which is 1, 2, and 2, and the unique subset containing only one element is only 1 and 2. We cannot include 2 2's here because this will generate the duplicacy problem. Anyways, the subset containing 2 elements is 1, 2, and 2, 2. And the subset containing all 3 elements is 1, 2, 2. And after that, we have to also consider the empty set as a subset. So we can say that there are 6 subset of 1, 2, and 2. Now let's understand the constraint. Here, the array length can be in between 1 to 10, and each of the array can be in between -10 to +10. Now, let us understand the actual algorithm behind the solution of this problem by using backtracking. Anyways, let's consider an input array which has 4 elements, which is 1, 6, 6, and 8. And for each element, we have two choices. Either we can take it into the subset or we can just ignore it from the subset. So at first, we are at element 1. So for element 1, we have two choices. Either we can take element 1 into the subset or we can ignore element 1. If we take element 1 into the subset, our subset will contain only 1. And if we ignore element 1 from our subset will remain empty. And now we have processed 1. So far, so good. Now we have to process the element 6. Here, from this one, either I can take 6 or I can ignore it. If I take 6 into the subset, then our subset will become 1 and 6. And if we ignore 6 into the subset, our subset will remain same. And from this empty subset, either we can take 6 into the subset and our subset will become 6, or we can ignore it and our empty set remain still empty. Now we have processed this 6 and now we are in the next 6. So in this 6, we have also two choices. Either I can take it or I can ignore it. If I take it into this 1 and 6 subset, our set will become 1, 6, and 6. If we ignore this 6, then our set will remain same, which is 1 and 6. Now, in this path, we have also two choices. Either I can take 6 into the subset or I can ignore it. If I take 6 into the subset, our subset will become 1 and 6. Okay, wait. This 1 and 6 exactly equal to this 1 and 6. So, in this case, if we take the second 6, we will end up with a duplicate value. Here, the intuition is, in this tree, we have included at least 1 6. So, we don't have to include at least 1 6 into any other tree. So, we can completely ignore at least 1 6 in this tree. It is the actual difference between the previously discussed subset problem and this problem, because in the previous discussion, all of the value are unique, but in this problem, there can be duplicate value. So we have to ensure that our resulting subsets can never be duplicates. So in this case, in this path, we have explored all of the possibility in which we have at least 1 6. So in this path, we don't have to include at least 1 6. because we have already explored it here. And by using this logic, we can remove the duplicacy. Now, let us understand and explore the entire tree. Anyways, for this one, we cannot take 6. So in this case, we have to consider the value of 8. So for the value of 8, we have also two choices. Either we can take it or we can ignore it. If we take 8 into the set, then our set will become 1, 8. And if we do not take 8 into the set, our set will still remain same, which is 1. Now we are in this 6. In this 6, we can consider the second 6, because if we consider the second 6, the resultant tree can contain at least 2 6. So the tree contains at least 2 6 is new for us. So we can consider the second 6 into this tree. Anyways, if we take 6 into the set, our set will become 6 and 6. And if we ignore 6, our set will still remain same, which is 6. Anyways, for this empty list, which value should I consider? Should I consider 6 or should I consider 8? For this empty list, we should consider 8, because from here we are going to this node if and only if we ignore the value 6. So in this tree, we cannot take any other 6, because in this path, we have already ignored it. So now, as we cannot consider 6 for this empty list, we have to consider 8. For the element 8, we have also two choices. Either I can take it or I can ignore it. If I take 8 into the set, our set will contain the value of 8. But if we ignore the 8 into our set, then our set is still remain empty. So far, so good. We have completed this level into our decision tree. Now again, for this set 1, 6, and 6, for the element 8, we have two choices. Either I can take it or I can ignore it. If I take element 8 into the set, our set will become 1, 6, 6, 8. And if I ignore element 8 into the set, our set will still remain same, which is 1, 6, and 6. Now, for this 1, 6, we can take 8 into the set. Then our set will become 1, 6, 8, or we can just ignore 8. So our set will remain same, which is 1 and 6. And for these two nodes, we have reached the base condition or the end of the vector, which is 8. So we don't have to explore the tree from here anymore. Anyways, for this node 6 and 6, we have to consider the element 8. And here we have also two choices. Either I can take element 8 into the set and our set will become 6, 6, 8, or I can ignore element 8 from our set and our set will still remain same, which is 6 and 6. Now, for this element 6, we have also two choices for the element 8. Either I can take element 8 into the set and our set will become 6 and 8, or I can ignore element 8 from our set, and for this, our set will still remain same, which is 6. And again, for this set 8 and empty set, we have reached the base condition or the end of the vector. So we can say that for the vector 1, 6, 6, 8, we have found 12 sets in this decision tree, which is this empty set, the set containing value 8, the set value of 6, 6, 8, 6, 6, 6, 6, 8, 1, 1, 8, 1, 6, 1, 6, 8, 1, 6, 6, and finally 1, 6, 6, 8, which is containing all the element. Anyways, here we can see that all of the leaf node of this decision tree is the subset of the given array, and none of the subset will contain duplicate. So here we can see that by exploring the decision tree in this manner, we can reach all of the unique subsets. And if all the value in the vector are unique, then our decision tree will contain 2 to the power n subsets. But here we can see that there are 4 elements presented in the array. So 2 to the power 4 is equal to 16. But there are only 12 leaf nodes. Anyways, this is why, because we are eliminating the repetitive subsets. That's why the leaf node becomes 12 instead of 16. Anyways, I hope you understood the problem and the algorithm. Now let's move on to the discussion of this code. In this code, at first we are given a function which is subsets with duplicate, and this function will return all of the subsets, and the parameter of this function is a vector. At first we have to sort the vector, and after that we have to declare a temporary vector and a permanent vector result, and we have to recursively call a backtracking function. Anyways, the first parameter of this function is the input vector. The second parameter of the function is the starting position of this decision tree, which is 0. The third parameter of this function is the temporary variable or the temporary vector. The fourth parameter of this function is the resultant vector, which is result. Anyways, finally we have to return the result. Now let's understand the functionality of this backtracking function. In this function, at first we have to insert the temporary variable into the result, and we have to run a for loop from the starting position to the end of the list. And inside each iteration, we have to check whether our current element is equal to the previous element. If it is, we have to just continue. We will not process the code beneath it. If our current value is not equal to the previous value, then for our current element, we have two choices. Either I can take our current element into the set, or I can ignore it. Here, I am taking the current element into the set, and after taking the current element into the set, we have to recursively call the backtracking function from the next element, which is I plus 1. And also we can just ignore the current element. In this case, we have to just completely pop the value from the back of the temporary vector. And finally, we have to return the answer. I hope you understood the code. Now let's move on to the time and space complexity of this program. In this program, the time complexity and the space complexity is big O of n into 2 to the power n, because for each element we have two choices. Either I can take it or I can ignore it. For this reason, the time complexity is 2 to the power n. And in the worst case, in each decisions, our temporary vector size can be equal to the original vector size, which is n. So we can simply say that our time complexity and space complexity is equal to the big O of n into 2 to the power n. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.